All right, let's get right into it. We're talking about the sun. You know, it gives us life, warmth, all that good stuff. But it also has this, well, this wild side, a fury that can unleash massive storms of energy right at us. And for years, we've been trying to guess when the next big one will hit. But now, a totally new approach using AI is letting us see the future. And not just next week. We're talking a full 100 years from now.
But hang on, before we get into the cosmic stuff, let's bring this right back down to Earth. Seriously, just imagine for a second. You wake up and your phone's GPS is dead. The internet is down because the satellites are out, and parts of the power grid are starting to fail. Now, this isn't some sci-fi movie plot. It's a very real threat from what we call a solar storm. And our super-connected, tech-heavy world, it's more vulnerable than ever.
And that's exactly why this is such a huge deal. We're diving into a brand new study that's completely changing the game. It lays out a way to forecast these massive solar events for the next 100 years. Yeah, you heard that right. A century-long weather forecast for the sun.
Okay, so to really get why the solution is so cool, we first have to get a handle on the problem itself. Let's talk about the sun's hidden danger and how all that solar activity can cause some serious chaos back here on our planet.
It really all begins with these things right here. Sunspots. Now, they might just look like little dark specks, but they are actually massive, churning areas of intense magnetic energy. A good way to think of them is like the dark, swirling clouds that build up right before a massive thunderstorm. They're the biggest clue we have that the sun is getting ready to do something big.
And when that activity really ramps up, the sun can let loose what's called a coronal mass ejection, or a CME. This is basically a billion-ton cannonball of solar plasma and magnetic fields being hurled into space. And if Earth is in the way, bam, it slams into our planet's magnetic shield and triggers what we call a geomagnetic storm. The fallout? It can mess with our communication networks, scramble GPS signals, fry power grids, and even pose a radiation risk to astronauts in space. It's a real threat to pretty much all the tech we rely on. So, for a long time, we've known that sunspots hold the key to prediction. But figuring out their patterns, well, it's kind of like trying to hear a beautiful melody in the middle of a hurricane. You know there's a pattern in there somewhere, but it's buried under a whole lot of chaos and noise.
What we do know is that the sun has a kind of heartbeat. It beats on a roughly 11-year cycle. It goes from a quiet period with very few sunspots, that's called the solar minimum, to a really active stormy period with tons of sunspots, which, you guessed it, is the solar maximum. This 11-year rhythm is the fundamental beat we're trying to track.
And this right here, this visualizes the whole challenge perfectly. Look at that top graph. That's the raw data. You can see the cycles, but man, is it messy. Now the graphs below it, that's where scientists pull out those clear, repeating patterns. But the real problem, it's that bottom graph. That's what's left over. All the random, unpredictable static. The noise. To really forecast the sun, you can't just predict the rhythm. You have to somehow predict the noise too. And that's incredibly hard.
So that brings us right to the heart of the forecasting challenge. Why is it so ridiculously difficult to predict what our own star is going to do next?
And you can really see the old way versus the new way here. In the past, researchers would often use a single AI model. And look, those were pretty good for short-term stuff, but they just couldn't see far into the future. They'd get lost. The new approach is totally different. It uses what are called hybrid and ensemble models. Just think of it like this. Instead of sending one person to do a job, you send a whole team of experts who all work together. The result is a much smarter, more stable forecast that can see way further ahead.
And this quote from the study just nails it. The data is nonlinear, complex, and cyclical. So what does that actually mean? It means it doesn't move in a nice, simple, straight line. It's a chaotic, unpredictable dance that has stumped even our best and brightest models. Until now. So how in the world do you solve a problem this messy? Well, you don't just throw a general AI at it. No, you build a specialized team. And that is exactly what these researchers did with their new AI forecaster. The secret sauce was creating these hybrid and ensemble models. Now I know, those are some pretty technical names, but the idea behind them is actually really intuitive. Instead of relying on one AI to do everything, they built a team where every single member has a very specific job. So let's meet the team. First up, you've got the detail spotter. This part of the AI is a master at finding those super fast, short-term changes, the sudden spikes and dips in activity. Next, you have the historian. This one has memory. It's fantastic at looking at the big picture, remembering the patterns from past 11-year cycles. And finally, you have the captain.
The captain takes all the intel from the detail spotter and the historian, weighs it all, and then makes the final call, the single best forecast possible. It's teamwork. All right, so the AI team has been assembled. It's crunched decades of data. So what did it find? Let's get to the really exciting part, the groundbreaking results of this century-long forecast. Just look at that number, 44%. When they put this new model up against the old state-of-the-art predictor, it was 44% more accurate on a yearly basis. And let me tell you, an improvement like that isn't just a small step, it's a massive leap. In the world of complex forecasting, a 44% jump is a total game changer. It means we can trust these predictions in a way we just never could before. And here it is. This is the payoff. The model's predictions for the peak of solar activity for the next 8 solar cycles. Look at that timeline. It takes us through 2024, 2034, 2045, all the way past the year 2100. This is basically a roadmap of the sun's fury, giving us decades of advance warning for when the solar storms are most likely to be at their worst. So that brings us all the way back to the beginning. I mean, a 100-year forecast is an amazing scientific feat, no doubt. But why does it really, truly matter to us? Well, it's all about protecting our future, both down here on Earth and as we start to venture further out into space. Because here's the bottom line. Prediction allows for protection. If you know a storm is coming, you can prepare. You can protect the things that matter. And in our case, that's the vital tech that our entire modern world runs on. Think about what this really means in practice. Power grid operators can take steps to prevent blackouts. Satellite companies can put their billion-dollar assets into a safe mode. We can make sure our GPS systems stay reliable. And, maybe most excitingly, as we plan to send people back to the moon or even to Mars, we can plan those missions for safer, quieter times in the solar cycle. It's a huge step forward.
And that kind of leaves us with one last big question to chew on. We've just seen how AI can help us predict the behavior of our own star a century from now. So as we get more and more connected, and as we push further and further out into the cosmos, what else can we do with this incredible tool? How else can we use AI to protect ourselves from some of the universe's oldest and most powerful dangers?